Okay, welcome to part 3 of the review, or my page 3. This is different than your page 3, but the numbers will in fact line up. So first we're going to determine whether the ordered pairs are solutions of the given equation. So in order to do that, we're going to use the property of substitution, substitute the x in the x, and the y in the y, and see if it gives us a true statement. So doing the substitution here, putting 4 in for x, we have 4 minus, plugging 3 in for y, 4 minus 3 equals 16, and this is in fact this fact is not true. So 4 minus 3 is 1. 1 does not equal 16. So no. So what we can say is that this ordered pair is not on the graph of that line because it is not a solution to this equation, or it does not satisfy that equation. So checking the second one, plugging the x in for the x, 4 times 3 minus plugging the 2 in for the y, 2 times 2. Does that equal 16? Well, 4 times 3 is 12. So this is 12 minus 4 is not equal to 16. So no, this is not a solution either, which once again means that this ordered pair 3, 2 is not on the graph of that line. Okay? So now we have a couple graphing linear equations. Now, we can graph using a couple different things because we have the machinery now. Right now, this is in that y equals mx plus b form. So from this, we can say that our m equals 3, or 3 over 1. So the slope, thinking of it as rise over run, up 3 and over 1. And the y-intercept is 0, 1. So let's plot that point, 0, 1. Go up 3, 1, 2, 3, over 1. We have a second point. 2 points uniquely determine a graph, and we have that right there. So using that right there, we could put this in slope-intercept form and graph this way. Now number 14, I'm going to do a little bit differently. For this one, I'm just going to find two ordered pairs. So I'm going to make a little xy chart, and I'm going to pick some values. Now I'm going to find the x-intercept and y-intercept because it's the easiest thing to do in this scenario. So to find the x-intercept, we're going to plug 0 in for y. So going over here, plugging 0 in for y, 5 times 0 minus 30x equals negative 30. Well, 5 times 0 is 0, so we have negative 30x equals negative 30, so we divide by negative 30. These cancel, we get 1, so we get x equals 1. So when y equals 0, x equals 1, or when x equals 0, y equals 1, this gives us this intercept right here, 1, 0. Now, we could plug another point in for y and solve for that, but it's just as easy. We just found the x-intercept to find the y-intercept. Now, to find the y-intercept, we plug 0 in for x. So, looking over here, plugging 0 in for x, we have 5y minus 30 times 0 equals negative 30. Well, negative 30 times 0 is 0, so we have 5y equals negative 30. Divide by 5. And we get y equals negative 6. So, when x equals 0, y equals negative 6. Of course, we could have plugged any numbers in for x and y to get ordered pairs, but 0 is easy to work with, it's easy to evaluate, and it's just a really great number to use. So here, 0, negative 6, that's our intercept. Plot the point there, 0, negative 6. Draw the line that goes through them, and we have graphed that line right there. So now we go down and we're looking at these. So we're going to find the coordinates of the y-intercept for the given equation. So to find the y-intercept, the coordinates, once again, we could get it in that slope-intercept form, but we could also just plug 0 in for x. That's another way of finding the y-intercept. So plugging 0 in for x here, 2 times 0 minus 4y equals negative 12. All this cancels. So you get negative 4y equals negative 12. Divide by our negative 4, we get y equals 3. So when x equals 0, y equals 3, so 0, 3 is our y-intercept. Number 16, once again, to find our y-intercept, we plug 0 in for x. Y equals 1/4 times 0. Well, 1/4 times 0 is 0, so we get y equals 0. So this goes through the origin, that point 0, 0. So it's both an x-intercept and a y-intercept. So that's this page. See you on the next page.